Hi, Sam here from Roberts Geospatial. Today I want to show you all of the transparency options in ProRaster Premium. So in computer graphics, we don't talk about transparency, we talk about opacity. And in ProRaster, everything refers to opacity. Opacity is the inverse of transparency. So if, for example, you have a 32-bit color, it'll have four 8-bit components: red, green, blue, and alpha. Alpha is opacity. So those opacity values range from 0 to 255. So at 0, you have no opacity. In other words, you're completely transparent. At 255, you have full opacity. In other words, you're completely opaque. So those numbers from 0 to 255 go from transparent to opaque. In ProRaster, we also talk about scaled indexes, and they go from 0 to 1. And again, that's 0 for transparent up to 1 for fully opaque. In terms of color, 0, of course, is black, and 255 is white. So it goes from black to white. That's perhaps a little bit counterintuitive, because for me, I think of it as going from white to black, where white is sort of transparent and black is, fully opaque. So let's just create an algorithm for a raster source, and just something like that. And I'll show you where all the settings are for opacity in ProRaster. So firstly, I'll click on the algorithm layer and go to the color page. So in here, you can see the blending rule. This is your primary control for opacity in ProRaster. And there are 4 settings there: override, overprint, LightTable, or blend. So you need to set that to the appropriate rule in order to enable blending in ProRaster. Then you've got blend with buffer. And here's the buffer background color. This is also important. This is the map background color here. So for example, I change that to white. It goes white in the background. But by default, it's this light gray color. And then there's a LightTable opacity control here. So this is 0 to 255. You set a value for your opacity. So that's at the algorithm level. Then at the layer level, again on the color page, you'll see there's an opacity value here. 0 to 255, you can control it with a slider, or you can type it in, or use these up and down controls. So that sets the opacity for a layer. And then in components, we have this opacity component. So this is for opacity modulation. So this is for varying opacity in a layer on a per pixel basis. So this is a component. You have to enter a raster source, and then on the color page, you have to choose a data transform. And there's also a lookup table option here. Now if you click it, it says you can't edit it, you can't edit this. But here is a bit confusing, so I'm indicating opacity here, and I've gone from white to black, which sort of made sense to me, which is the opposite of the truth, which is it's from black to white. But this is indicating that we're going from transparent to opaque. And the color table, which is just an opacity table, is fixed in that case. Alright, so let's get started and just look at an image. So I'll bring this image in. Here's a TIFF file. Now this is a TIFF file that has got 4 color components: red, green, blue, alpha. So it has alpha burned into the color values. So if you move over the thing here, you can see that it's got red, green, blue, A, and the A value there is 5. If I move out here, it's 19. Here, up here, where it's largely opaque, it's closer to 255. So we've got sort of blending opacity in here and in here and up through here. So let's come up to our algorithm layer and go to color page. So by default, the algorithm blending mode is in overprint. So let me explain these modes for you. So the first one is override. What that says is we're going to override any opacity settings. You can really think of it as just being a switch off for all opacity. So if I turn this to override, I get full color saturation come back in my raster. You can see that it's still got opacity values. You know, here it's 10, but we're not using them anymore. We're not using them, and so it comes out as fully saturated color. So that's override, essentially turns off all opacity. If I was to turn on this opacity modulation, it wouldn't do anything. If I go to the layer and I try to adjust this opacity for the layer, it's disabled. You can't do anything. So in that mode, override, everything's switched off. The second mode is overprint, and this mode really only exists for imagery like this, and actually it's kind of redundant. You can choose overprint or you can choose blend and you get the same effect. We put on overprint, so now we're keeping the alpha value in the imagery, so we're not throwing that away. And you can see that it's blending with the buffer color, because we've got blend with buffer turned on. So it's blending out to a kind of grey color. If I turn that off, then it's like we get no blending at all. So we still have alpha values, but we're not blending with the buffer. So it's so we're seeing full saturation. We can change this buffer color to white. You see now it blends out to white. So that's overprint mode. Again, if I go into a layer, I still don't have control over this opacity slider. I can't change the opacity level for a layer, and opacity modulation is still disabled. And that's why instead of overprint mode, you might choose blend mode instead, because then those things are enabled and you get the same effect. So overprint, kind of redundant. Okay, so let's look at the LightTable blending mode. So I'll just open this algorithm. So this algorithm has got 3 layers. So on the bottom we have Google Maps layer. Then the second layer on top of that is global DTM. Then the third layer on top of that is some magnetics for Australia. So just to demonstrate, so let's just zoom in, say here in Australia. So there's my top layer, which is a reduction to pole. If I turn that off, then I can see the terrain underneath it. If I turn that off, then I can see Google Maps underneath that. So turn my terrain back on, turn my reduction to pole back on. So go into the algorithm color page, and now I'm going to change the blending rule to LightTable. So now this LightTable opacity slider becomes active. On the layer property pages, I still can't adjust the opacity individually for layers. So all of the opacity is adjusted from here, and also the opacity modulation via components is still not active. So the LightTable opacity applies to every layer. So if I bring it down, then it's going to make the reduction to pole and the DEM that sits on top slowly more transparent. The thing about LightTable mode is that it's different to blending mode. It simulates a light table where you have a table that's lit from underneath, and you put your map on top of it, and you lay your maps one on top of the other, and you look through them. So the maps that are overlying each other are blended together, but the maps that aren't overlain by anything else will still have full opacity. So that's why you're seeing out here the Google Maps, which is the bottom layer, has still got full opacity, and then the layers on top of it are then blended out. So you can adjust this up and down. So if we go higher opacity, then we're seeing these top layers. Lower opacity, they slowly get blended out until right down here we see almost nothing but the bottom layer, which is Google Maps. So that gives you that control allows you to easily control the opacity of all of the layers in your algorithm through one control. So let's now take a look at blend. So this is the full on blending mode. So our LightTable opacity goes away, now we can come into each individual layer and edit the opacity individually. So I can turn this one right down. This is the RTP, and go into the DEM and turn that one up. That's not really blend out, say sorry, we had a little technical problem there. So go into DEM, bring that down. You can see that's blending that out. Go into Google Maps, bring that up. So now I have, say, full saturation on Google Maps, full opacity, and then in the DEM above it, I've got that kind of blended out a fair bit, and then in the reduction to pole above that, I'll bring that perhaps up a little bit. So that gives you the opportunity to control the opacity of every single layer, and unlike LightTable mode, the bottom layer you can also control, so that I can blend out the Google Maps if I want to, which is the one on the bottom. Okay, so that gives you control over each individual layer. It also enables opacity modulation. So let's take a look at that. Let me get rid of that layer, that algorithm. So we'll just create a new algorithm. We'll just do this reduction to pole. So here's good old magnetics for Australia. So let's modulate this by itself. So I'll turn on the opacity, and immediately the picture disappears. That's because my opacity component is not valid, and so it's invalidated the whole algorithm. I've got to choose a raster source, got to choose my field and band, and then I need to choose a data transform. So let's do, say, equal area transform. I need to come up here and turn my blending on, and now you can see, let's come back to the opacity layer. So we've got a histogram equalization transformation equal area, and we're going from transparent up to opaque. So in other words, we're going to make everything that's the low colors blend out, and we're keeping all the high colors. And if you look at the color table, so blues are going to get blended away, and then we're going to keep the reds, and the greens are going to be intermediate. And you can see that's what's been achieved here. We've all the blues in between are fading out to the background color, keeping the reds, and the greens gradually fade out. So that's where we're opacity modulating something by itself. So let's put something underneath this. So let's add Google Maps into there underneath, for example. So go into the image. Just got to load that Google Maps. That's in program data, GE, web maps. Here's Google Maps. So I'll just zoom to the Australia. So now we're looking at visualization where we have maps underneath, and then our magnetic data on top. So our highs are essentially opaque, whereas all of our lows are transparent, and so we can see the maps coming through. So let's make this a little bit more complicated. So this is magnetic data. It's reduction to pole. If everything was if induced magnetism was the only effect in the Earth, then in a reduction to pole magnetic map we'd see sort of a base level and then just highs poking out of the base level. So we just have high anomalies. But in reality, rocks are remnantly magnetized, and so things that are negative anomalies are also of interest, as well as things that are positive anomalies. So in this data, we have lows, which are of interest. We have data in the middle, which is not a lot of interest, and then we've got data that's high, and that's of interest too, if we're looking for magnetic anomalies. So what I want to show now is how we can display those lows and display those highs and blend out everything in between. So what we need is a data transform on our opacity, which is like a V, like a notch. So we're going to go from low, being opaque, and we're going to go down the notch to 0, where we're transparent, and then back up the other side to make it opaque again for high values. So let's go into the data transform editor, and we'll add a new transform. And I'm going to call this reduction to pole notch transform. Oops. Now, we're going to create this using a table. So I'm going to put index against data value. So I'm going to use index for value. And it's created a table for me here. Now I'm just going to set the rows to 5. I need 5 rows. So I need to create a data transform. Let's choose a raster. So we're seeing something that makes sense. We need to create a data transform over the whole data range. So I need to go from, kind of minus infinity up to positive infinity. So, so we'll start off at minus infinity. There'll be some large negative number. 100,000 is going to be enough for this. And I want my lows to be opaque, so we'll put in index of 1. That's opaque. And then I'm going to go up to the beginning of my V-shaped notch. So I'll put in negative 1,000. That's also going to be opaque. Now I go down the notch at 0, and that will set to 0, so that's transparent. Up the other side of the notch at 1,000, we'll set that to 1. And now, just to complete the function, we'll put in positive infinity, and that's also at 1. So that's my function. So you can imagine it's like a line graph. We want to make sure that it interpolates between those points. And that's actually set here on the transform page. It says full color table. Well, actually that means it's going to interpolate, so it's a bit of an odd label, but in this case. But you need to switch that on. It's switched on by default. So let's go OK. That saves that. Now we'll go into our opacity modulation, go to the color page, choose from our stored transforms, and there's our RTP notch transform. So here's the effect. So perhaps let's zoom in here. Where's a nice let's find a nice spot. I suppose it's all right. So here you can see that our red highs are opaque, and our blue lows are opaque, but in between we can see Google Maps poking through. So I could probably improve that transform, probably could take out more blue and take out a bit more red and make it more transparent. But you get the idea. We've created a data transform function which allows us to vary that transparency across that data set. So here's an example of a low which we've kept next to a high which we've kept, and in between we're seeing through it into our maps. Okay, so that's opacity modulation. We've looked at opacity with images. We've looked at opacity by layer, and we've looked at opacity modulation. You've seen all the controls. The only other thing to mention is exporting. So I need to save this as something before we can export. Temp, save. Okay, so I'm going to export. So in export, you can see that there's a color format here. So red, green, blue, A, or you can choose 24-bit red, green, blue. So if you want to output any of these opacity values that you're generating in your raster algorithm, then you'll need to choose RGBA as an output format. And you can see there are some other options here. Make valid pixels opaque, make invalid pixels opaque, and make invalid pixels valid. So there's some options there to change that. And the other thing that I want to mention about exporting is back here, back in our algorithm color page. You can see that we've still got blend with buffer turned on, and our buffer background color is grey. Now that means that we're injecting grey into the imagery. When you export, you probably don't want that. So you either want to change that to a white background color, or turn off blending with the buffer before you do your export. Otherwise, you're going to put some grey into that export. Whereas what you really want is no colour at all injected into it. And then when you bring that image into some other application, like a GIS application, then you blend with their background colour, whatever that is for the map. So that's an important option just to remember when you're exporting. So that's opacity and transparency in ProRaster Premium.